In this lesson, I'm going to be giving you an introduction to forces. So by the end of this, you should be able to explain what a force is, you should be able to calculate net forces, and you should be able to compare and contrast balanced and unbalanced forces. So what is a force? The most basic, easiest way to think about a force is it's a push or a pull. So if you look at my picture here, this finger is pushing this toy car, which is causing it to move forward. So the finger is applying the force, which is causing the car to move. So, can there be more than one force on an object? Well, of course there can. So an example would be that gravity is pulling you down to earth, and the ground is supporting you, and your legs are moving you forward as you're running during Phi Ed. So you've got force 1, which is pulling you down to earth. You've got force 2, because the earth is pushing back up on you. And then you've got force 3, which is moving you forward. So in this example, there are 3 different forces that are being applied to you in just one situation. So let's say you're sitting on your couch listening to this video. Well, currently you have 2 forces acting on you. You've got gravity pulling you down, and you've got the force of the couch pushing you back up. So you're not moving anywhere, but you have 2 forces acting on you. So there's generally always more than one force acting on something. So net forces. When we talk about there being more than one force acting on something, we're generally talking about the net force when we calculate it. So the net force is the total combination of forces that are acting on the object. So for the running example, the net force would be figuring out the total force acting on the object between forces 1, 2, and 3. And in order to calculate this net force, we need to take the direction they're going into consideration. So if they're moving in opposite directions, you're going to subtract. So if you have something moving this way and something moving this way, you're going to subtract them. If they're moving in the same direction, you're going to add. So if one's moving this way and then another one's moving this way, you're going to add them together. So this might be bringing some memories of something else that we've done in class recently. This is very similar to calculating resultant velocity. It's the same concept, same idea. Going in the opposite direction, you calculate the velocity they're moving in total by subtracting the 2 numbers. Going in the same direction, you just add them together. So it's the very same concept between resultant velocity and net forces. The only difference is what we're talking about. So let's do an example. If you're moving into a new place and you asked your sister to help you move the couch. Well, she ever so stubbornly agreed, but since she doesn't want to, she's not going to work as hard as you. So if you're working at 25 newtons and she's only doing 20 newtons of work, but you're moving in the same direction, what's the net force? So remember I said if you're moving in the same direction, you're going to add them together. So you're working at 25 newtons, your sister is working at 20 newtons. Well, so your net force is going to be 45 newtons of work. So let's try another one. So your parents just bought you and your brother this brand new game for your Nintendo Switch. It's the hottest game. You've been waiting for weeks. You've been begging your parents. And so you wanted to play it first. It's only a single player game. There is no multiplayer option. But your brother also wants to play it first. So now you're fighting over the Switch. And if you're pulling on the Switch with a force of 10 newtons, and your brother's pulling on the Switch with a force of 10 newtons, well, what's your net force? So you're going in opposite directions because imagine you're here, The switch is here. Don't judge my artwork, it's terrible. You're pulling this way. Here. You're pulling this way. He's pulling this way. Okay? So you're pulling in opposite directions. So we're going to subtract the two numbers. Well, if you're pulling at 10 newtons and he's pulling at 10 newtons, your net force is 0 newtons. So as of right now, neither one of you are going to get the switch, and more likely, it's going to fly out of your guys' hands, smash into something, and break. So if this truly happens in your household, make a compromise. Don't break your expensive switch. So now let's talk about balanced forces. So a balanced force is one in which the net force is 0. So the calculations we just did, this one here, this is a balanced force because there is no motion. In reality, you guys are pulling it, but the switch isn't moving anywhere because you guys are pulling at the same force. Like these two cats here. They're sitting on a seesaw, but they're not moving, and the seesaw is straight across. It's not tilted in any direction. So this would be a balanced force because let's assume they both weigh the same because it kind of looks like they weigh the same. Their net force is 0. So just remember, balanced forces, no motion. So here's some more examples. You've got some people playing tug of war here. The first group is pulling with 400 newtons to the left. The second group is pulling with 400 newtons to the right. Well, they're not moving anywhere because 400 minus 400 is 0. What about these people standing on the beach? Well, they're not moving because, I mean, you look at the picture and you see they're standing still, but you can see that the ground is applying 50 newtons upwards, holding them up from the ground, and gravity is pulling them at 50 newtons down. So 50 minus 50 equals 0. So very big key point. Always remember, balanced forces equals no motion, which equals a net force of 0. So anytime your net force is 0, you have balanced forces. But now let's talk about unbalanced forces. Well, an unbalanced force is when an unbalanced force is when the net force is greater than 0. So there's gonna be motion in this case. So look at these cats again. Yes, they look the same weight, but now all of a sudden the seesaw is tilted. So that means the cat on the left is applying more force to the seesaw than the cat on the right. So the net force would be greater than 0. Well, what about these examples? So let's do the skydivers. The skydivers have gravity pulling them down at 50 newtons, but they've got air resistance pushing them back up at 2 newtons. So 50 minus 2, well, that's 48 newtons. So the net force is greater than 0. So that means they're moving. They have an unbalanced force being acted upon them. What about the tug of war picture here? Well, that's not fair. The blue team has 3 people, whereas the purple team has 2. So the blue team is pulling with a force of 40 newtons. The purple team is pulling with a force of 25 newtons. So 40 minus 25, that gives us a net force of 15 newtons towards the blue team. So there is an unbalanced force acting here because the net force is not 0. So key point to remember with unbalanced forces. If the net force is not 0, that means there's going to be motion, which then means that it's an unbalanced force. So, only in unbalanced force can change the motion of an object. So let's use this little picture of the person and her dog here. Your dog can cause you to move if he pulls with enough force. And if you have a big dog, even some small dogs, they have so much power behind them that they could probably pull you flat on your face. So if his force is greater than the force that is causing you to stay in place, you're going to move. So this also kind of relates to acceleration. A change in motion also means a change in velocity and a change in acceleration. So, but what if the object is already moving? Let's say you're running down the road. What would happen if an unbalanced force is applied to you as you're running? Well, if an unbalanced force is applied to an object that's already moving, it's going to change the speed or direction of the object. Again, dealing with acceleration and velocity. So an example would be your little brother is riding on his tricycle. You run up behind him and you decide to give him a big push. Well, your force adds to his existing force, causing him to speed up, causing him to accelerate. You can apply an unbalanced force to something that's already moving. But can these forces act in the same direction? Well, of course they can. So let's say you're pushing a cabinet across the room with a force of 15 newtons, while your friend is pulling it with a force of 10 newtons. Well, what's the net force going to be? So you're moving in the same direction because you're pushing and your friend is pulling. So calculating the net force, we're going to add these together. So we have a total net force of 29 newtons. And we want to know what direction it's moving in. Well, if your friend is pulling it, that means it's going to be moving in the direction which is towards your friend. So unbalanced forces, they can be acting in the same direction, they can be acting in opposite directions. Balanced forces are not going to be acting in the same direction because that would cause them to have a greater net, that would cause their net force to be greater than 0. Let's try another one. We've got two dogs here. Their names are Bob and Frank. They are tugging on a rope. Well, one dog, that's Bob, is pulling at a force of 20 newtons. The other dog, Frank, is pulling with a force of 25 newtons. So what's the net force? Well, they're pulling in opposite directions, so we need to subtract this. Well, we've got 25 minus 20. Well, that gives us an overall of 5 newtons. So that means this is an unbalanced force. And which direction is it pulling in? Well, if you look at it, Frank has the greater amount of newtons, so it's going to be pulled towards Frank. Looks like he's got the one up on Bob. Alright, so now let's just do a little bit of recap for this lesson. So remember, a force is a push or a pull on something. The net force is the total combination of forces acting on the object. If they're moving in the same direction, you add. If they're moving in opposite directions, you subtract. Balanced forces means there's no motion and the net force is equal to 0. And unbalanced forces means there's motion and the net force is greater than 0. This is the end of the forces introduction lesson. If you have any questions, as always, write them down in your journal or send me an email or text message if you feel they're pretty dire. Otherwise, have a great day.